Hello everyone, and welcome to PadhaiX. In this video, we'll solve NCERT Class 11 Physics, question 3.17 from the chapter Motion in a Plane. Let's first read the question carefully. Question number 3.7. Position of a particle is given by r equals to 3t minus 2t squared Joule meter, and the coefficients have the proper units so that r is measured in meters. Part A. Find the velocity and acceleration of the particle. Part B. Find the magnitude and direction of the velocity of the particle at t equals 2 seconds. Now that we've understood the question, let's solve it step by step.
We have a particle, and its position vector is given as r equals 3ti minus 2t squared j plus 4k. Before jumping into the calculations, let's first understand what this equation tells us. Notice that the position vector depends on time. This means as time changes, the position of the particle also changes. Let's see how. When t equals 0 second, the position vector becomes r equals 0i minus 0j plus 4k. So the coordinates of the particle are 0, 0, 4. This means at the very beginning, the particle is located at the point 0, 0, 4. Now let's see what happens after 1 second. Substituting t equals 1 into the position equation, we get r equals 3i minus 2j plus 4k. Therefore, the coordinates become 3 minus 2, 4. So after 1 second, the particle has moved to this new position.
Let's check the position at t equals 2 seconds. Putting t equals 2 in the equation, we get r equals 6i minus 8j plus 4k. Hence, the coordinates are 6 minus 8, 4. Notice something interesting here. The z-coordinate remains constant at 4, while the x and y coordinates keep changing with time. Now let's move to part A. We need to find the velocity and acceleration of the particle. We know that velocity is the time derivative of the position vector. That is, v equals dr/dt. And acceleration is the time derivative of velocity. That is, a equals dv/dt. Therefore, velocity equals differentiation of 3ti minus 2t squared j plus 4k with respect to time, which is equal to 3i minus 4tj plus 0k. So this is the velocity vector of the particle. Now let's differentiate the velocity vector once again. Differentiating 3i minus 4tj plus 0k with respect to time gives a equals 0i minus 4j plus 0k. So the acceleration vector is simply minus 4j meter per second squared. Thus, we have obtained both the velocity and the acceleration. Before moving to part B, let's visualize this velocity vector. Understanding its components will make the next part much easier. Let's first look at the x-axis. The x component of velocity is plus 3 meters per second. Since this value is constant, the particle always moves along the positive x direction with the same speed. Now look at the z-axis. The z component of velocity is 0, so there is no motion along the z direction.
Finally, let's observe the y-axis. The y component
is negative 4t meters per second. Notice that this component changes with time. At t equals 1 second, it is negative 4 meters per second. At t equals 2 seconds, it becomes negative 8 meters per second. And at t equals 3 seconds, it becomes negative 12 meters per second. So as time increases, the particle moves faster and faster in the negative y direction. Now that we've visualized the velocity, let's solve part B. We need to find the magnitude and direction of the velocity at t equals 2 seconds. Substituting t equals 2 into the velocity equation, we get v equals 3I minus 4 times 2j plus 0k. Therefore, v equals 3I minus 8j. This means that at 2 seconds, the particle has a velocity of 3 meters per second along the positive x-axis and 8 meters per second along the negative y-axis. Now let's calculate the magnitude of this velocity. Using the magnitude formula, the speed becomes the square root of 3 squared plus 8 squared. This is equal to the square root of 9 plus 64, or the square root of 73. Hence, the magnitude of the velocity is 8.54 meters per second. Now let's determine its direction.
Suppose the velocity vector makes an angle theta with the positive x-axis. Then, tan theta equals vy over vx, which is minus 8 divided by 3. Therefore, theta equals tan of minus 8/3. This gives theta equals minus 69.44 degrees. The negative sign tells us that the velocity vector lies 69.44 degrees below the positive x-axis. Final answer. The velocity vector is 3I minus 4tj meter per second. The acceleration vector is minus 4j hat meter per second squared. And at t equals 2 seconds, the particle has a speed of 8.54 meters per second, making an angle of 69.44 degrees below the positive x-axis. And with this, we have successfully solved NCERT Class 11 Physics, question 3.17. If you found this explanation helpful, don't forget to like the video, share it with your friends, and subscribe to PadhaiX for more NCERT physics solutions. Thank you for watching, and I'll see you in the next video, where we'll solve question 3.18.